Good morning and Assalamualaikum to all. Regarding yesterday questions, so I would like to explain. So yesterday I received a questions about for dual voltage supply. Okay, in example 2. Okay, why there are minus part here? Okay, why there are minus part? Sorry, not minus part. Why there are R1 instead of R2? Okay, so to explain that, I would like to start from the beginning, which is the Thevenin theorem. Okay, the Thevenin theorem. So Thevenin theorem is a theory or a method that we simplify the circuit. Okay, we simplify the circuit and make the circuit easier to be calculated. So there are two analyses. Okay, there are exact analysis and there are also approximation analysis. If you remember yesterday, right? Approximation analysis. Yeah, approximation analysis. Okay, approximation analysis. For approximation analysis, okay, for you to decide if which analysis that you want to use, the condition for approximation analysis must satisfy that the beta resistor at the emitter must be greater, okay, 10 times with resistor R2. Okay, so if this condition is satisfied, then we can use the approximation analysis. But if this condition is not satisfied, then we need to use exact analysis. All right, so for exact analysis, okay, so if you are using the Thevenin theorem, okay, for voltage divider circuit, okay, since that there are two resistor, okay, there are two resistor parallelly connected. So what you have to do first is we need to simplify this method first. Okay, because when you are simplifying, so in this case, we are using only one or single voltage supply in this case. Yeah, only VCC voltage supply, and this is grounded, so only one voltage supply. So in this case, if you want to use the Thevenin theorem to simplify this circuit, it will look like this. Okay, it will look like this. Okay, it will look like this. And the resistor of R1 and resistor of R2 is parallelly connected. So by using the resistor theory, if resistor is parallelly connected, so 1 over R total, R Thevenin, so it will be 1 over R1 plus 1 over R2. Okay, so this is to find R Thevenin. Yeah, so rearrange this equation, you will get R Thevenin will be R1 plus R2 over R1, R2, not R1 plus R2. R1 times R2 over R1 plus R2. Okay, so I think this one you can calculate it by yourself and you can confirm it by yourself. Okay, you will get the result of R Thevenin. Okay, R Thevenin will be R1 R2 over R1 plus R2. Okay, so this is because this is parallelly connected. So if you want next, we need to find voltage Thevenin. Yeah, voltage source Thevenin. So Thevenin voltage. So Thevenin voltage is at this point. Okay, at this point. So ETH, it is parallelly with resistor R2, right? So we know that voltage, if it is parallelly connected, the value is same. Okay, the voltage at here is same voltage to here. So we will say Thevenin voltage is equal with voltage R2. Okay, voltage R2, voltage that flow at R2. So how to find this voltage? Okay, how to find this voltage? Since that this is an open, open, right? So it means that it is not connected. So it means that all the currents is flow in this loop only. It will not enter to this part because this is not connected, right? This is open circuit. So let's choose one loop. Yeah, so let's decide we are using this loop. Okay, we are using this loop. So based on Kirchhoff voltage law, okay, first of all we need to find the currents, right? To find the voltage that flow here, we need to find the currents flow here. So the currents that flow at R2 is same currents flow from at R1, because no currents will flow here since that this is not connected. This is an open circuit. Yeah. So since we need to find the flow of currents, yeah. So first of all, if you want to find the flow of current based on the Kirchhoff voltage law, okay. So this is minus, this is positive, positive, minus, positive, and minus. Okay, so positive VCC, okay, minus I currents that flow from resistance R1, yeah, minus, and then minus with currents times resistor R2, okay, will equals to 0. Okay, so since that the currents flow here is same with the currents flow here, we can say VCC minus I R1 plus R2 equals to 0. Okay, equals to 0. Next, we can rearrange this. You will get the value of I is equals to VCC over R1 plus R2. Okay, so now we can find the voltage at VR2. Okay, so voltage at VR2 will be I, which is this value, okay, VCC over R1 plus R2 times with the resistance value. Yeah, this is from the Ohm's law. Okay, so you will get this equation, right? So this will gonna be the Thevenin voltage for this simplified circuit. Okay, so this is for single voltage source. Yeah, single voltage source, only VCC the voltage source. Now, okay, so this is the part for the single voltage supply. Okay, single voltage supply. So you will get that the value of Thevenin voltage is R2 times VCC over R1 plus R2. Okay, as I showed just now, how to find the value of this voltage. Okay. All right. Next, let's look what will happen if the voltage supply is 2. For example, from yesterday's example, example number 2, if I'm not mistaken, there are 2 voltage supply, which is VCC and also VEE. Okay, this is positive 20 and this is minus 20 volts. Okay, if there is 2 voltage supply, there are one condition that need to be fulfilled. Okay, that you have to memorize this. Yeah, when VCC voltage supply on, okay, VEE voltage supply will be grounded. So it means that there is no, this will not be counted. So this is going to be grounded. And vice versa. So it means that if VEE voltage supply is on, so this voltage supply, VCC voltage supply, will be grounded. Okay, this is going to be grounded. All right. So there are 2 cases here. It can be both cases. Yeah? Either VCC is on or VEE is on. So we need to consider both cases. Yeah. So first of all, if VCC voltage supply is on, VEE voltage supply will be grounded. And then another case is VEE voltage supply is on and VCC voltage supply is off. All right. So in that case, the voltage, the Thevenin voltage will be, okay, E prime TH, where this is when VCC voltage supply on and VEE grounded. Okay, and E prime T and E prime TH, okay, and E prime TH, it means that VEE is on and VCC is grounded. So you need to consider both cases. That's why we need to plus this, yeah. So E prime TH is for VCC on and VEE grounded. E prime prime TH, VEE on, and the other one we're gonna be grounded. Okay, so to find the total voltage, Thevenin voltage, you need to plus both cases together. All right. So in this case, I decide that E prime TH, VCC is on, and VEE is grounded. This is VEE. Okay, in this case, VEE is grounded, and E prime prime TH, VEE is on. Okay, VEE is on, and VCC is grounded. Okay, next, you need to do is you need to design the circuit, how the simplified circuit gonna be. All right, let's look here. All right, so for when the VCC is on, okay, when the VCC is on, VEE is grounded, right? VEE is grounded. We need to ignore this part, right? We need to ignore this part. So the circuit we're gonna look like this, right? VCC goes to R1, okay, because VCC is connected to R1, and then from R1 it is parallelly connected to R2. Okay, parallelly connected to R2. Okay, there is since that it is parallelly connected, so it means that there is another wire here, and then connected to VEE, but VEE is grounded. All right, in this case, yeah. So for this, I think no problem because this is same with single voltage supply. But then next, for E prime prime TH, since that we are considering this voltage is on and this voltage is off, it is easier for you to turn this circuit the other way around. Okay, flip the circuit the other way around. Okay, to make it easy, to make it clearly for you to look. Okay, so if you turn this circuit the other way around, you can see that VEE is connected to R2. Okay, and then parallelly connected with R1. And then from here, since that it is parallelly, the voltage of E prime prime TH is going to be here. Right? So again, yeah, if you are confusing why it is the configuration is like this, what you need to do is turn this circuit the other way around. Okay, turn the paper the other way around. It will look like, oh, it will the connection, the configuration should be like this. Right? Okay, so now once you get the configuration correct, okay, the position of R1 and R2 for each E prime TH and E prime prime TH correct, what you need to do is you need to calculate the value of E prime TH and E prime prime TH. I think for E prime TH shouldn't be any problem because it is same with single voltage supply, right? So E prime TH, so it will be choose one loop as same like before, choose one loop, okay, use the Kirchhoff voltage law, so you will get that this is minus, this is positive, this is positive, this is minus, yes, this is positive, this is minus. Again, only currents flow from R1 is same with the currents flow to R2, okay, since that this is an open circuit, yeah. And then you will get the value of the currents. When you get the value of the currents, okay, so E prime TH same with the voltage flow from here at this point at R2. So E prime TH is equals to the voltage at R2. So since that we have calculated the value of I and we already know the value of R2, so you can get that E prime TH, this is the value. Right? So next, you need to calculate for E prime prime TH. So for E prime prime TH, okay, E prime prime TH, okay, the voltage of VEE is minus, right? So it is it's the voltage come from the minus source polarity of the If it is battery, then battery. Okay, so it comes from the minus polarity. So this is positive, this is minus. Currents enter to the resistor should be positive, come out minus, enter positive, minus. Okay, so we are choosing this loop. Okay, but if you are choosing the other way around, it should be this part should be positive. Yeah, all right. So since I'm choosing this loop, okay, so minus VEE, since that the currents come out from minus here, minus VEE minus, because this is minus as well, minus current flow from R1, and then minus with current flow minus I R2. I currents times R2 equals to 0. Since, yeah, this is same, the reason, yeah, why the reason of I is same as before, means that current flow from R2 is same with current flow to R1 because of this is not connected. This is an open circuit. So rearrange the equation. Okay, rearrange this equation. You will get the value of I is this. Okay, so value of I, value of E voltage Thevenin, E prime prime TH, you will get minus VEE over R1 plus R2 times with the value of R1. Okay, times with the value of R1. Right? So to find the total Thevenin voltage, E prime TH just now plus with E prime prime TH, so you will get the total of Thevenin voltage is this. Okay, so this is going to be the total of Thevenin voltage. So to answer question yesterday, why it is R1? So the reason because of the VEE is connected. The configuration of VEE when VCC is grounded is like this. Okay, okay. So and E prime prime TH is parallelly to resistor R1. Okay, so I hope it's very clear with this explanation. Okay, so thank you.